Hello everyone. In this video, we will solve the questions based on the topic of week 11. So here are some tips to solve the questions. Okay. So first of all, we identify each trial and see whether we can classify the outcome of the trial as success or failure or not. Okay. Then we try to find out the total number of trials in the question, right? Okay. Then we check whether our trial are independent and identically distributed or not. So what is the meaning of independent here? So independent trial means the outcome of one trial should not be dependent on the outcome of the other trial. Okay. So these are the trials which are of independent of each other. Okay, an identical trial means that the probability of success in the each trial should be same. Okay, so if an experiment satisfies all the above properties, then we say that it is a binomial experiment. Okay, so what we have to do? So whenever we are given an experiment, first of all we check whether we can classify the trial as success or failure or not. Okay, and then we check whether the trials are independent and identically distributed or not. Okay, so if both of these properties or conditions satisfied, then we can say that it is a binomial experiment. Okay, now the question number 1 is, following are the experiments: 1. Tossing an unbiased coin for 100 times and counting the number of heads. Option 2, question 2, tossing a biased coin for 100 times and counting the number of heads. And 3 is choosing 5 balls randomly from an urn containing 20 yellow balls and 20 red balls without replacement and counting number of red balls chosen. So which of these is not a binomial experiment? So the first one is each trial should have either success or failure as an outcome, and n should be fixed, and all the trials should be independent and identically distributed. Okay, so these conditions we have to check here. Okay, so in the experiment number 1, we can say the number of trials is fixed. Okay, so here we can see that coin is tossed 100 times. Okay, so value of n will be equal to 100 here. Okay, now we can see that for each trial, if we get head, then it is success, and if we get tail, then it is failure, right? So here the outcomes are classified into two types: success and failure. Okay, and since the coin is unbiased, so we can say that the probability of getting a head or probability of getting a tail will be 1 by 2. Okay, so here we can see that probability of success is same for each trial. Okay, so the trial will be identical also, right? So here we can see that all the conditions for binomial random variable are satisfied. So experiment number 1 will be the binomial experiment. Okay, now we will see for the experiment number 2. So here also we can see that we are tossing a biased coin 100 times. Okay, so n will be equal to 100 here. Okay, now here we can see that we can classify the outcomes in success or failure. So if we get head, then it is a success, and if we get tail, then it is a failure. Okay, now here also we can see that suppose since the coin is biased, so the probability of success, suppose it is C, then probability of failure will be 1 minus C, right? So here we can see that the trials are identical also, because for each trial the probability of success will be same. Okay, so here we can see that the trial will be independent to each other and also identical to each other. Okay, so our experiment number 2 will also be a binomial random experiment. Okay, now the experiment number 3. So what is the experiment number 3? So here we are choosing 5 balls randomly from an urn containing 20 yellow balls and 20 red balls without replacement. Okay, and counting the number of red balls chosen. So here we can see that number of balls we are taking is 5. Okay, we can see here that we are selecting 5 balls randomly, so n will be 5. Okay, now we can see that for each trial, if we get red ball, then it is a success, and if we do not get a red ball, then it is a failure. Okay, so the outcomes for each trial can be classified as success or failure. Okay, Now for the first trial, the probability of getting a red ball will be 20 divided by 20 plus 20, because 20 yellow balls and 20 red balls are there. Okay, so selecting the first red ball, so this probability will be equal to 20 divided by 40, which is equal to 1 by 2. Now for the second trial, probability of getting a red ball. Okay, so suppose the first ball that we have chosen, if it is red, then only 19 balls will be left in the box. Okay, so we are taking 19 box, and total we are having 39 balls. 39 balls, because one ball is already chosen. Okay, now suppose if we have selected the first ball, but it is a yellow color ball. Okay, so in this case there will be total 20 balls in the box, total 20 red balls in the box, and total number of balls including red and yellow, that will be 39. Okay, so if the first picked ball is yellow, then the probability of getting or selecting the second red ball will be 20 divided by 39. Okay, so here we can say that the probability of getting a red ball, or we can say that the probability of success is changing from trial to trial. Okay, probability of getting red ball in the second trial is not same as the first trial. Okay, so it is changing. So here we can see that the trial will also not be independent. Okay, because the outcome of the second trial depends on the outcome of the first trial. So here the trial are not independent and not identical. So experiment number 3 will not be the example of binomial experiment. Okay. Now again we have some steps to solve the further problems. Okay. So what we do, first we try to identify the event in the given question. Okay. Then we try to find out the probability of success. Okay. So and then we identify binomial random variable and the number of trials. What is the number of trials? It is n. Okay. So we find out these things and we check for all the properties. Okay, so all the properties if satisfied, then it will be a binomial random variable. Okay, then further we can use the PMF or the expression for the binomial distribution. Okay, so expression for getting I success in the n trials is given as this. Okay, so we can use this PMF and calculate the probabilities. Question number 2. An archery trainer wants to test the archery skills of newly joined students, which includes some prodigies, skilled or talented. The trainer puts up a circular board of radius 20 meter. If the student shoots an arrow in the region of radius 5 meter, then the trial is considered as success. Okay, the student undergoes 3 trials and need to get at least 2 successes out of the three trials to pass the test. Prodigy is a student who has very good archery skills when compared to the normal students. Okay, now what is our question? What is the probability that a normal student will pass the test? Assume for a normal student there is equal chance that the arrow will land anywhere on the board. So how we will solve this question? So here we can see what is our random experiment. So random experiment is shooting an arrow onto the circular board, right? So the binomial experiment is getting a success in throwing an arrow to the region of radius less than 5 meters. Okay, so which means that if you're throwing an arrow in the region of radius less than 5 meters, then it will be a success. And if we throw an arrow beyond the region of 5 meters, then it will be a failure. Okay. Now, how we will calculate the probability of success here? So, probability of success will be directly proportional to the area of that region in which we are considering the success, which is of 5 meters here. Okay. So, in the question it is given that if the student shoot an arrow in the radius of 5 meters, then the trial considered as success. Okay. So the what will be the area of the region of success? It will be pi r square. So r is 5 here. Okay. So the area will be pi 5 square, which is equal to 25 pi. Okay. Now we will calculate the total area of the board. So we can see that the total the circular board, the radius is 20 meters. Okay. So the total area of the board will be pi 20 square, which is 400 pi. Now we will calculate the probability of success. Okay, so the probability of success will be the area of the success region and the total area of the circular board. Okay, so the success area, which was radius of 5 meters. Okay, so this area is 25 pi divided by the total area, which is 400 pi. Okay, so the probability of success will be equal to 0.0625. Now we have calculated the probability of success. Okay, probability of failure will be 1 minus probability of success. Okay, now here in the question we can see that the student undergoes 3 trials. Okay, and need to get at least 2 successes out of the 3 trials to pass the test. So here we can see that the number of trial is 3 here. Okay, now we are redefining a random variable x, which is the number of successes among the 3 trials. Okay, so the probability of getting I successes among the n trials will be given by this formula. This is the PMF for binomial random variable. Okay, and how the success is defined here? If the student get at least 2 successes out of the 3 trials, then then he will pass the test. Okay, so passing the test will be equal to probability of probability at point 2 plus probability at point 3. Okay, it is probability that x is greater than or equal to 2. So by using the PMF, we can calculate these probabilities. Okay, so probability of passing the test will be equal to 0.011224, which is 1.12% approximately. Now some more tips to solve the questions. Okay, so first of all, we try to identify the binomial random variable. So we know that the expectation and variance, expectation is NP and variance is NP1 minus P for the binomial random variable. Okay, where P is what? P is the probability of success in a trial and Q is the probability of failure in that trial. Okay, now we can use the equations of the expectation and variance to find the unknown values of the N and P here. Now question number 3 is, if the variance and expectation of getting number of tails in tossing a biased coin is 1.05 and 3.5 respectively, then what is the probability of getting 3 tails? So here in the question, what is our experiment? Experiment is tossing an unbiased coin. Suppose let x is a random binomial random variable that represents the number of tails here. Okay. Now here we are given the expectation of and variance. Okay. So expectation is what? Expectation is equal to NP and variance is equal to NP 1 minus P. Okay. So what is N? N is the number of trials. Okay. And P is the probability of success. Okay, now we will put the values which are given to us of expectation and variance, and by using the equation 1 and 2 we can find the value of P and N. Okay, so substituting the value of P in equation 1, okay, we will be getting the value of N also. Therefore the probability of getting 3 tails in the 5 tosses is given by this. Okay, what is it? NCX P to the power X 1 minus P to the power N minus X. So here we can see that N is equal to 5. Okay, and what is X? X is 3. Okay, and probability of success we have calculated it 0.7 and 1 minus P will be 0.3. Okay, so here we can see that the probability of getting 3 tails in the 5 tosses will be equal to 0.3087. Question number 4. Ritika wants to test whether the coin she has is a fair coin or not. To test this, she conducted an experiment of tossing the coin 4 times. Binomial random variable x is defined as the total number of heads after 4 tosses. Okay, so this is the probability mass function for the random variable is given. Okay, now what is the probability of getting a head? So here we can see that she is tossing the coin 4 times. So the n number of trial will be equal to 4. Okay, and for x is equal to 4, the probability is 0.0256. Okay, now we know what is the formula or PMF for binomial distribution. Okay, which is this. Now we have to put the value of n here and we will be getting the value of p. Okay, So value of n is 4. Okay. And here what is I or x, which is 4. Okay. Now, after putting the values, the value of p will be 0.4. Okay. We can use any other point also. Here we have calculated by using the probability at point 4. We can use the we can find the probability by using some other point also, like 0. Okay. So that will also give us the same result. And there is an alternate method also. We know what is the expectation formula in the binomial random variable. It is NP. And how we calculate expectation for a random variable? It is summation of I into probability at point I. Okay. So the probability mass function is given to us in the question. So by using this, we will calculate the expectation of x. Okay. That will be equal to 1.6. Now 1.6 will be equal to n times p. N is given to us as 4. So from here also we can find the value of p, which is 0.4 here. Question number 5. If the variance of a binomial random variable for n is equal to 8 is 1.92, what are the possible values for p? If more than 2 values are possible for p, enter the values of p separated by comma. So here we can see that the number of trial is given as 8, right? And variance of x is given to us 1.92. Okay, and we know what is the variance in the case of binomial random variable. It is np 1 minus p. Okay, so from here we can write that np 1 minus p will be equal to 1.92. Value of n is given to us. So from here we can find the value of p. Okay, so when we will put the value of n here, we will be getting a quadratic equation in terms of p. Okay, so we will solve this quadratic equation, and the roots of this quadratic equation or the value of p will be 0.4 or 0.6. Okay, so two possible values are here for p. And there is a note point that values of p is equal to c or 1 minus c. That give us the same variance. Okay, where c lies between 0 and 1. Okay. Now the question number 6 is, in a box there are 10 chocolates, of which 6 are milk chocolates and 4 are dark chocolates. 2 chocolates are drawn at random without replacement from the box. Now question is, what is the expected number of dark chocolates drawn? So total 10 chocolates are there, out of which 6 are milk chocolate and 4 are dark chocolate. Okay, so suppose let x is a random variable that represents the number of dark chocolates, okay, from the box. Suppose so x is following the hypergeometric distribution in this case. Okay, 6 milk chocolate and 4 dark chocolates are there. Okay, so we know what is the formula for for expectation in case of hypergeometric distribution. It is mn divided by capital N. And what are these? Capital N is the total number of chocolates. So total number of chocolates here are 10. Okay, and m represents the number of dark chocolates. Okay, since here x, the random variable x, is representing the number of dark chocolates. Okay, so m will be the total number of dark chocolates in the population. So m will be equal to 4. And n represents the number of chocolates selected. Okay, here we are selecting 2 chocolates, so n will be equal to 2. So now we will put all the values in this formula and we will get the value of expectation of x, which is 0.8 here. Question number 7. A car hire firm has 2 cars which it hires out day by day. The number of demands for a car on each day is distributed as Poisson distribution with mean 1.5. Calculate the proportion of days on which neither car is used. So here suppose x is a random variable which denotes the number of demands for a car on any day, and it is following the Poisson distribution, and the mean is given to us as 1.5. Okay, so here x is following the Poisson distribution with lambda is equal to 1.5. Okay, now we know what is the formula or the PMF for the Poisson distribution. Okay, it is e to the power minus lambda, lambda to the power x divided by x factorial. Okay, now what we have to find? We have to find the probability of days on which neither car is used, which means the number of demand will be equal to 0. Okay, there is no demand. So we have to find the probability at x is equal to 0. Okay, by using the PMF, we can calculate it. Okay, and it will be equal to 0.223.